Every structure follows 4 rules. Break just one, and it fails. Not because the material is weak, but because of how it behaves under load. Those 4 rules are strength, stiffness, stability, and synergy. Most people only think about strength, but strength alone is not enough, because structures don't just fail by breaking. They fail by bending, by becoming unstable, or by not working as a system. To understand why structures succeed or fail, you have to understand how all 4 work together. Let's start with the most intuitive: strength. Strength is the ability to not break. When a beam carries load, it develops internal forces. The top gets compressed, the bottom gets stretched, and if those forces become too large, the material fails. That's the simplest form of structural failure. And in brittle materials, like concrete or unreinforced masonry, this can happen suddenly with almost no warning. So strength is about survival. But here's the problem: a structure doesn't have to break to fail. And this is where most people misunderstand how buildings work. Because many failures don't start with breaking, they start with bending. This is stiffness. Stiffness is the ability to resist deformation. 2 beams can carry the same load without breaking, but one might bend much more than the other. And that difference matters, because excessive deflection creates real problems. Floors feel soft, beams visibly sag, walls crack, doors stop closing properly. The structure is still standing, but it's no longer performing. That's a stiffness failure. And stiffness is not just about material, it's about geometry. Here's where things get interesting. Take a single wooden board, it bends easily. Now take multiple boards. If you just stack them, nothing really changes. They still bend, but if you connect them, so they act as one piece, everything changes. Now the structure becomes dramatically stiffer. Not twice as stiff, not 10 times, but sometimes hundreds of times stiffer. Same material, same amount, completely different behavior. And the reason is simple: material placed farther from the center works harder. So when you make a beam deeper, you're not just adding material, you're placing it where it matters most. That's why a tall beam is exponentially stiffer than a flat one. And this is one of the most important ideas in structural design. Performance is not just about what you use, but where you put it. Now, even if a structure is strong enough and stiff enough, it can still fail. Not by breaking, not by bending too much, but by losing its balance. This is stability. Stability is the ability of a structure to maintain its position and shape under load. Because sometimes failure doesn't come from the material, it comes from the geometry. Take a vertical column. Under compression, you might expect it to simply crush. But in many cases, it doesn't. It bends sideways and collapses suddenly. This is called buckling, and it can happen even when the material itself is strong enough. What matters here is not just the material, but the proportions. A short, thick column can carry a lot of load, but a tall, slender one can fail much earlier. Same material, same load, completely different outcome. Because instability is driven by shape, and the dangerous part is, it happens suddenly. There's often no visible warning. The structure looks fine right until it isn't. And this doesn't apply only to columns. Entire systems can become unstable. A frame without proper bracing can collapse sideways under lateral forces, like wind or seismic movement, even if every beam and column is individually strong enough. Because stability is not about individual elements, it's about the system as a whole, maintaining equilibrium. So strength prevents breaking, stiffness controls bending, but stability is what prevents sudden collapse. And without it, everything else can fail instantly. Now, even if a structure is strong, stiff, and stable, there's still one more thing that determines how it actually performs. And this is where design becomes much more interesting. This is synergy. Synergy is the ability of all the parts to work together as a system, because a structure is never just one element. It's a collection of components. Beams, columns, connections, and how they interact can completely change the outcome. Take a simple example. A single wooden board is easy to bend. Now, take several identical boards and stack them together. You might expect the stack to be much stronger, but if they're just placed on top of each other, they still behave independently. They slide, they separate, they don't share the load effectively, so the performance barely improves. But now, connect them, glue them, fasten them, make them act as one piece, and suddenly, everything changes. Now the load is distributed across the entire section. The elements stop working individually and start working together. And the increase in performance is not small. It's dramatic. Same material, same quantity, completely different behavior. And this is the idea behind engineered systems, like laminated beams and framed structures and well-designed connections. Because in real structures, the connection is often more important than the element itself. A strong beam with a weak connection is still a weak system. But when everything is connected properly, the structure becomes more than the sum of its parts. That's synergy. And this is what ties everything together. Strength, stiffness, and stability define how individual elements behave, but synergy defines how the entire system performs. So in the end, a structure is never judged by just one quality, not by strength alone. Because something can be strong and still fail. It can bend too much, it can become unstable, or it can simply fall apart because the parts don't work together. Real performance comes from balance, from getting all four right: strength, stiffness, stability, and synergy. Miss one, and the system breaks. And once you start seeing structures this way, you realize something most people miss. Failure is rarely about the material. It's about the design. Because the same material, arranged differently, can either fail or perform exceptionally. And that's the real difference between something that just stands and something that's truly engineered.
This is Builder Brief. We're building a space for serious, system-level conversations about housing, land, and construction beyond headlines and beyond politics. Our goal is simple: to understand how the built environment actually works and why it affects all of us. If you find this work valuable, consider subscribing and supporting the channel. It helps us continue producing independent, data-driven analysis like this.